The Pythagorean theorem is used if you have a right triangle and you know two of the side lengths, but you're missing the third. Recall, first of all, that a right triangle contains one right angle. The side opposite the right angle is called the hypotenuse. The other two sides are called the legs. So, for example, here's a right triangle. Maybe this side is length 3 and this side is length 4, and you probably guessed because this is the most famous Pythagorean triangle, but 3, 4, the hypotenuse is 5. So the hypotenuse again is the side opposite from the right angle. So even if you oriented this triangle in a different way, if it's a right triangle, we need to know where the right angle is. So the side across from it is called the hypotenuse, and the other two sides are called legs. So there's a leg and there's a leg. So going back to the first triangle, that's a leg and that's a leg. The Pythagorean theorem tells us that the square root of the hypotenuse of a right triangle is equal to the sum of the squares of the two legs. So the theorem, if I write it out for this first triangle, the hypotenuse is C because it's the side across from the right angle. So the theorem would state that if you square and add the other legs together, it's equal to the hypotenuse squared. It seems funny that I've written the side lengths with F and M and P on the second triangle, but just to make a point, again, the hypotenuse would be F here because it's across from the right angle. So the theorems would tell us that m squared plus p squared is equal to f squared. And of course it doesn't matter the order. I could write p squared plus m squared equals f squared. That's fine. Examples where you're going to use this include this first example. The length of one leg of a right triangle is 8 inches. The hypotenuse is 12 inches. Find the length of the other leg. So we're told that we have a right triangle. So first we'll draw a right triangle. We'll label the one leg that's given as 8, and the hypotenuse is 12, and then the other leg is unknown. The Pythagorean theorem would tell us that the unknown side squared added to the other leg squared is equal to the hypotenuse squared. So x squared plus 8 squared equals 12 squared. If I go ahead and work some of this out, x squared plus 64 equals 144. I'll solve for x, so I'll subtract 64 from both sides. And I get x squared equals 80. Next, to solve for x, I would have to take the square root of both sides because I have x squared and I need x, so I take the square root. So I get x equals the square root of 80. That's the exact length, but it's unsimplified. So remember, we know how to simplify square roots. Square root of 80 can be simplified because 80 has a factor that's a perfect square. 4 is a factor that's a perfect square root, but we can find one bigger than that because 16 is a factor. 16 times 5 is 80. So the reduced answer is 4 root 5. That's the exact form of the answer. Sometimes the homework question might ask you to give the approximate answer to 2 decimal places. So in that case, you would say the square root of 80, I put that into a calculator and I round it to 2 decimals and I get 8.94. That's an approximate answer, and the other answer is exact. It just depends on what you're asked for. In my last example, I'm told that the two legs of a right triangle measure 12 feet and 9 feet. Find the hypotenuse of the right triangle. So I draw my right triangle, I label the two legs that I know, and I don't know the hypotenuse. I set up my equation. The legs squared and added together equals the hypotenuse squared. So 144 plus 81 equals x squared. Add 144 and 81, that's 225. I want to solve for x, and I know what x squared is, so I'm going to take the square root of both sides. The square root of 225, that's a perfect square root because there is a number that you can multiply by itself that equals 225. It happens to be 15. So the hypotenuse of this right triangle is 15.